Welcome to this video on the topic of algebra. In this video, I'm going to show you the process called collecting like terms. To do this, I'm going to go over 5 unique examples. Now, looking at example 1 here, we have 3x plus 2y plus 5. And the objective here is we want to do something called collecting like terms, or another way to put it, what we want to do is we want to rewrite this such that we don't have repeated variables across the expression. So when we're looking at, say, 3x plus 2x plus 5, what we want to do is we want to see it as something x plus 5. Now, looking at this, what we have to do is we need to collect what are called like terms. So like terms being variables, or terms I should say, have similar variables. So notice we've got two terms, both containing x, and then we've got this constant by itself. What we're going to do is we're going to grab the two terms that have x's in them. We're going to open up some brackets, and then I'm going to write the coefficients inside the brackets here. So 3 and 2. Outside the brackets, I'm going to put the variable x. Then to finish it off, I'm going to put my plus 5 constant. Completing the job, I'm going to go 3 plus 2 is 5, so I'm going to write 5, remove the brackets, put the x. Then, to clean it all up, I'll put my constant. And thus, what I've done is I have collected like terms. So, the third line here, the third and final line here, is in a much more compact state than this original first line here. So this is what we want. Now, example 2. In example 2, we have y plus 5y minus 2y. What we're going to do is we're going to collect like terms such that rather than having a 3-term expression, we're going to have a single-term expression. So we're dealing with a y, a plus 5y, and a minus 5y. Alright, now, if I were to add these together, I'm a little bit unsure of what I'm going to do with the y here. But if I remember back, when we have a variable all by itself, what this actually means is that there's an implied 1 in front of the variable like so. So when we go to collect like terms, what's going to happen is I'll open up the brackets and put the y at the back like before, but I'm going to start off with this 1, the implied 1, then go plus 5, and then plus, but rather minus 2. Then collapsing it all together, 1 plus 5 is 6, take 2 is 4, so we get 4y. So this is our new expression. What we have here is 2x minus y plus 3x plus 2y. Once again, what we want to do is we want to rewrite this expression in its most compact form possible. So what we're going to do is we're going to collect all of the terms. But what we're going to notice is when we're looking at these terms, it's not just the same variable across all of the terms. Rather, we've got x's and we've got y's. So rather than highlighting everything, what I'm going to do is I'm going to go back and I'm going to give the color green to my terms with x's in them, and then the color pink to my terms with y's in them. Now, next step is I'm going to rearrange this expression such that all of the terms involving x are next to one another. So I'm going to get 2x plus 3y. So I grab the plus and the 3x and I move them forward. Then I grab this negative y and I throw it 1 back. And then finally I put my plus 2y at the end. Now, color coding, just so I don't make mistakes. And then I notice this minus y by itself over here. To deal with this, I'm going to put an implied 1 in front, just so I don't make any mistakes. Now, I'm going to open my brackets and throw the x down. Then I'm going to go 2 plus 3. Next step, I'm going to put a plus down, open my brackets, and then throw down the y. Then I'm going to go minus 1 plus 2. Reason it's minus 1 is because there's a minus in front of the 1 here. Alright, now cleaning this up, 2 plus 3 is 5. write the 5, drop the brackets, write the x, plus -1 plus 2, or 2 take 1 is 1. So write the 1, drop the brackets, put the y. Now, I don't need this 1 in front of the y because whenever there's a 1 in front of a variable, it's always implied. So we can drop the y and simply write the variable. Alright, example 4, we're moving along. In example 4 we have 3x plus 2x squared plus x squared minus 4y. Once again, we're dealing with x's and y's. So what I'm going to do is I'm going to go through and highlight all of my terms with x's in them. And then I'll highlight my terms with y. The sole -4y out there by itself. Now, this looks all well and good, but it's actually not going to work. And reason being is because we have these powers. So we've got the power that is 2 here, but not the 2 here. What we're going to find is we can't mix variables, or we can't mix terms involving variables that are different powers. So we cannot add coefficients of terms with variables raised to different powers. So what that means is this should not be green here or here, but rather we'll give it the color blue. Alright, so collecting like terms, what I'm going to do is I'm going to put my 3x down here. Then I'm going to open some brackets because I've got 2x squares and put an x squared at the back. Then I'm going to go 2 plus my implied 1. Then we're going to go minus 4y. Simplifying this up, we get 3x plus 3x squared minus 4y. And we are done. We cannot simplify, or we cannot collect any further terms to make this smaller. Rather, we have to represent this expression using 3 terms. But it's better than the 4 terms we started with. So not too bad. Now, example 5. We have 3 pi plus 2i minus 4e minus 2 pi minus I plus 3e. What we want to do is we want to collect our like terms. So doing that, once again, what I'm going to do is I'm going to identify all of the terms in this expression. So I've got pi's, remembering the negative always belongs to the term. Then we've got i's, and finally we have e's. What I'm going to do in the first step of collecting like terms is I'm going to put all of the like terms together. So I'm going to put my pi's at the front. Then I'm going to put my i's in the middle. And then I'm going to finish off with my e's at the back. Cleaning this up, we're going to open the brackets, drop the pi, put the 3 minus 2. Add the plus, open some brackets, put the 2 and the -1, -1, then put the I at the back. Put in the plus, open the brackets, put in the -4, +3, and then throw the e at the back. Cleaning this up, 3 minus 2 is 1, so I'm going to get 1 pi, plus 2 minus 1 is 1 I, plus -4 plus 3, so we're going to get minus 1e. Now remember, I don't need to write with the implied 1 in front of my variables, so I can write it as pi plus I minus e. And then I'm going to go for a cosmetic change, and I like to have my plus i's at the back always, so I'm going to write pi minus e plus I. And then we are done. So this has been a video demonstrating the process involved in collecting like terms.